All right, continuing on with our work for Lab 2. All right, so what I wanted to do next is talk a little bit more about instantiating modules within Verilog. Okay, so if you'll recall, we're trying to look at putting four functions together into one top module. All right, so this is called the top, and you're going to see that we instantiate four different versions of logic functions. And it's important to know what are the inputs and the outputs for the module that you're working on. So let's start here. Logic function top is what I have here in the RTL diagram. And so if I want to define a module, that's what I'm doing this step. This is, you notice this is the file name for logic function top. I'm trying to define this module. So I will start with the module keyword. I'll give the name of the module, just like we've talked about before, and then I'll define the ports. All right, what's different about these ports is I'm using vector notation. When you're defining vectors, you put the size in front of the variable. If you're using the vector later on, we'll put the brackets behind the variable. Okay, so keep that in mind. All right, so we have an input, it's a wire, it's 4 bits long, 0 through 3. 0, 1, 2, 3 is 4 bits. All right, and then it has an output that's out vec that's 0 through 3. So I defined the ports. The next thing I need to do is instantiate different things that show up according to the diagram. So the first thing I see here is that there's logic function 3, logic function 2, logic function 1, and logic function 0. In this diagram, I put them from top to bottom because to me it just naturally fit to have the most significant bit at the top and the least significant bit at the bottom. Notice in this code, it doesn't matter what order we instantiate things in. It doesn't matter what order you put a circuit down in. You have the circuit working. Everything works in parallel. That's the thing about Vivado. So I could have started with function 3. I can also start with function 0. All right, so let's look at the diagram for function 0. This is why the diagrams are useful. This tells me the ports of function 0 are P, Q, R, and S, and the output is F0. All right, so if you were writing this code, you would need to know where to start. Okay, and so you would start with nothing. Let me delete some of these things. Okay, so you'd start with not knowing what to do. All right, so let's clear this and put it back in. Okay, so the first thing you do is you say, okay, I want to connect the inputs. So the dot tells me, oh, I want to put the first input, dot P, and I look at the diagram, that goes to invec 3. Okay, so I click in here, invec bracket 3. That's what I'm talking about. The brackets are behind when you're accessing the data instead of just defining it. Okay, so comma. All right, then the next one, I look at the diagram, I see that dot Q, input Q, is connected to invec2. And then there's always a comma separating all these parameters, okay? And then dot R is in vec1, comma, and dot S is in vec0. All right, so I get that from the diagram. That's the input side. This comma is misplaced. All right, and then finally, I have to worry about the output as well. So I look at this, take care of inputs, take care of the output. The output is dot F0, and that goes to outvec. Okay, so this is passing by reference. It didn't matter what order we put these in. I mean, it's natural to use the order from the diagram, but you could put this in any order and this would still work. All right, so that's the rest of this. So if you compare the RTL diagram to the way these are instantiated. So I put the label name of the module. Oh, and then I forgot to put, you need to have something that tells which instantiation we have of that particular module. So for example, if we're going to put down an adder, you might have two adders within a circuit. So how would you know the difference? Well, it turns out each each thing that you instantiate has to have a label. So this is the module name. The label can be anything you want within reason. Okay, so this is something that just helps you keep track of which module gets instantiated. So that's the pattern: module name, the label, and then defining the ports. Okay, so that's another practice at instantiation.